All right, so we're going to go ahead and get started with our first EPID 403 exam review. So this is for exam 2 coming up. And I posted a few questions that we're going to work through in this session. And we'll email those out to everyone that wasn't able to attend. And I believe it was sent out through the listserv as well. So this exam is focusing on looking at probability, risk, measures of association, and study designs. So hopefully these problems will give a good overview of those things. Okay, so we have the first question here, and you have it with you, right? Okay. So this one's looking at age-related maculopathy, and it's a leading cause of blindness among people 65 and older. So there's just a paragraph here describing this study. So age-related maculopathy is a leading cause of blindness among people 65 and older in the United States. In a recent study by Klein, residents aged 43 to 86 years in the town of Beaver Dam, Wisconsin, were asked to participate in a study to determine whether cigarette smoking was related to the age-related maculopathy. And at baseline examination, the participants were asked to report their lifetime smoking habits. After 5 years, participants then had an examination to determine whether they had developed the age-related maculopathy. And so then there's a table presented below that shows the number of cases of the age-related maculopathy measured at follow-up for the 1,232 male participants who did not have the disease at baseline. And so then I'm just going to write the data up on the board so everyone can see that. So we're looking at smoking. So for the never smokers, there was a total of 368. And then any smoking, there were 864. And then out of those, the people that then developed the age-related maculopathy, we call those just cases of ARM. So for the never smokers, there were 26, and the ever smokers, there were 79. So the question that I have for you all is, which of the following best describes the research design that is used in this study? So the options are population-based cross-sectional study, a case cohort study, nested case control study, prospective cohort study, or none of the above. So kind of based on the information that they gave you in the paragraph above, what kind of study design do you think this is?
Well, I would think it would be the population-based cross-sectional study, just because you're talking about two different things. But
So what are the characteristics of a cross-sectional study? So typically it's set up how?
I'm not sure.
So just think back to like kind of how they describe it in the book. So a cross-sectional study is usually just looking at a snapshot in time. So whenever you're looking at your exposure and your outcome, you're looking at it all at once. So you would be doing a survey on a population and you would ask them, like, right now at this point, have you smoked? And then you would ask them at that same time point, do you currently have whatever disease that you're looking at? So in this case, if it was the ARM, they would ask them right then, do they have it? So based on that, in this study, are they asking them like at one time point, or does it look like they're doing something different?
Looks like they're doing something different.
Okay. So it says in the paragraph that they asked them to participate, and then they determine at baseline, they asked them to report smoking. And then after 5 years, then they had an exam to determine if they developed the disease. So in that case, since they're following them for 5 years, that would be a cohort study. And specifically, it would be prospective. Does that make sense?
Yeah.
Okay.
Yeah.
Because anytime that you see that they're following a group of people for a certain period of time, then it's either going to be a cohort study or an experimental trial. And because here, since they aren't randomizing anyone, you know that it's not a trial. So then it has to be a cohort study. And because they're following them into the future, it's prospective. And
trials and the characteristic of trials is that it's always some kind of randomized.
Yeah, so for an experimental trial, it's usually that you are starting with a sample of people and then you randomize them into receiving either the treatment or the placebo, and then you follow them to see who gets the disease and what the outcomes are. All right. So that kind of answers the first one. Any questions on that so far? Okay. And then if anyone on the online has any questions, once again, just type them into the box and then I can answer things in the chat box as well.
How are you?
Good, how are you? Okay, so moving on to the next question. So there's you found the questions. So now it's asking to just create a 2x2 table based on this data that's on the board. And so they've given us like some parts of the 2x2 table, but now we just have to complete it and fill it out all the way. So what would be your first step for completing a 2x2 table for this based on what they gave you? And I'll give you a second to look over it.
It occurs to me I'm confused about what goes on which cell.
I think I have an idea.
Okay.
Should I just say it or what?
Yeah. So
Okay.
yeah, we can talk through your answer, and then we can also talk through like approaches and things like that, if that would help you. Okay. All right. So what are your thoughts?
Break it up to those who are exposed and not exposed. Or
Yes.
unexposed.
Yes.
And then those who have arms or arm, and those who don't. So, like I don't know, like should I?
Yeah.
Like I'm trying to think of how I was talking to you. So okay, so
Yeah.
for those,
Or if you want to come up and
Oh,
like,
okay.
write it up here, you
I'll
can do
write
that
it.
too. Yeah.
Okay. All right, use this one so it'll show up.
You'll have to write kind of big
Oh,
so they can, because we're recording it,
oh,
just so
okay.
people can see. So just try to like talk through your process.
Oh wow.
No pressure.
Used to that, yeah.
I
Okay.
mean, everyone's kind of learning, so that's good.
So again, separating it by those who are exposed and unexposed, and those who have the disease and those who don't.
Yes.
So, right, exposed on top, unexposed below, or rather on the side, and then on top, all right, arms, disease, whatever, and then no disease.
Yes.
Okay, so for those who are exposed and have the disease, it's 79 cases?
Yes.
Okay.
And then just be sure to write that exposed means that you smoke, just so people know what
Should I
exposed
write
means.
that? Like,
Yeah.
Okay, so smokers.
Yeah.
And non-smokers.
Yeah.
Okay, so then we have 79 people who have been diagnosed with ARM, and then we have 26 people who were not smokers but were diagnosed with the disease.
Yes.
And then we have 368 people who were never smokers and don't have the disease.
Yes.
Okay.
Or wait, hold on 1 second. So this 368 is actually all
I'm sorry. Okay.
non-smokers.
All total non-smokers.
Yeah. Yeah, because whenever you see N, that just means like total. So this is just like everybody that was not a smoker.
I see. Okay, so then this should be, the total should go here.
Yeah.
Okay, so that would be 864. I'm sorry for not talking properly. So then you have to subtract.
Yeah.
Okay, so then to get the amount of people who were smokers and don't have the disease, you subtract 79 from 864.
Other way around.
Okay.
864.
Oh, from okay.
Minus, yeah.
Okay. And so you get 785. So that goes in the exposed smokers who don't have the disease, 785.
Yeah.
And then for the unexposed non-smokers and those who don't have the disease, you subtract the 368 from 26. Okay. And you get 342.
Yes.
All right. Okay. That's about all I can do.
No, that's good.
Okay.
Yeah, so I can just kind of reiterate what she has done for everyone. So the first thing that you want to do is anytime you're trying to set up a 2x2 table, you want to first identify what's your exposure and what's your outcome. And here, smoking is the exposure, and then the age-related maculopathy or ARM is the outcome. So the first thing you want to do is just label the left side smoking, non-smoking, and then the top is going to be ARM, no ARM. Is everyone with me so far?
Mm-hmm.
Okay. And then it told you that the total number of people that never smoked was 368. So like I was saying before, anytime you see a big N, that means like this is a total amount of something. So you know that your row total for your non-smokers should be 368. So then you know that you can just go ahead and put that out here on the side, because these sides are always like your totals of things. And then it said there's 26 cases of the ARM among those never smokers. So then you know that has to go in the cell for non-smokers with ARM. So the 26 goes here. And then you just do the same thing for the people that have smoked. So your row total is 864. So that goes out here in your marginal. And then 79 of the people that have smoked have ARM. So then that goes in the smoking ARM cell. So then you've got these two numbers and then these two, and then you can just subtract. You can do the total minus this cell to get the other cell, because these two should always add up to the marginal. And then the same thing for the row for the non-smokers should add up to the marginal. And so the last thing that I would also do is I'm just going to move this so we can put in, I would also fill in these totals as well, because you want to like make sure that everything adds up the way it's supposed to. So here you just have 79 plus 26. So that becomes 105. And then here you're going to have 785 plus 342. So that's 1127. And then these two together should give you your overall total, as well as these two together. So that becomes 1232. So that's a good way to check to make sure all your numbers are right, because this and this together should equal that, and then this and this together should equal the 1232. All right, any questions so far? I can go back through any of this if needed. Okay. You good, Walter?
Yeah, I mean that was a really good note.
Okay.
Yeah.
All right. So now we have our 2x2 table. So the next question is asking us to calculate the risk of age-related maculopathy in the ever smoking group as well as in the never smokers. So take a few seconds or minutes to think about how we would calculate risk in each of these groups. Does anyone remember the formula for risk, or what is risk in general?
I know that it's related to incidents.
Mm-hmm. Yes.
So
it is related to incidents.
So I know we should find the denominator.
Yes.
So I'm trying to think. So for the ever smokers,
Mm-hmm.
would that be 864?
It would be, yes.
Okay.
Because that's your total number of ever smokers. So I'm just going to write it. This is questions. That was part B. Okay. All right. So we're doing ever smokers. So we said the denominator was 864.
Yes.
Because that's the total number of ever smokers. And so then what would our numerator be?
Okay, so it's asking for those who have the disease. So of that, then it would be 79.
Yes. So just in general, anytime you're looking for risk, it's going to be the number of new cases divided by the total population at risk. Because you're trying to see, out of everyone that could possibly get the disease, how many people then got it. And so it told you that you started with 864 in the ever smokers. And then after they followed them for that 5-year period, 79 of them got it. Okay, so that gives you 79 over 864, which comes out to be
0.09.
865. No,
what was your question? Did you have a different denominator?
Yeah, because you know what? I did it by I divided the exposed arm by exposed no arm instead of the total.
Oh, okay.
Okay.
Yeah. Yeah, it turned off. They were on and I tried to play it with the music.
This turns like a
But I don't know. Okay, now seriously, I did that and it did not.
I believe you.
I truly did. Okay, thank you. Okay. So did you understand the denominator for this, or did you need?
I think I do need to understand that better.
Okay. So if we are talking about, we're trying to calculate what is the risk of getting this disease among people that have ever smoked.
Right.
So thinking back to our risk formula, risk means you're looking at the number of new cases in that group divided by the total population at risk in that group. So because our population here, we said we're looking at all the people that have ever smoked, the 864 was our total number of people that have ever smoked. Because they gave that to us in the beginning. And that's also our marginal total that we put over here from our 2x2 table.
Right.
So this is all the people that have smoked. So think about it as like you have sort of like this pool of people that have smoked, and then you're trying to look out of that pool of people how many people then got the ARM. And so out of that 864, 79 got ARM. Okay. And so we said this becomes 0.091. Okay. So that's your risk for this group. So you would normally just leave it like this. You don't have to like do anything else to it because it's just asking you just for the risk. And risk is a probability, so you just write it as a decimal here. All right. So now we also want to do the never smokers. Okay. So how do we get the risk for the never smokers?
So the total number of smokers, which is 368. That's the denominator.
Yes.
The number of and the number of people who develop the disease would be 26 of the never smokers.
Yes.
So I got 0.0706. I don't know if that should be rounded up or.
Yeah, we can just do 0.01
Oh.
or 0.71.
Okay.
Yes. So here we just did the same thing that we did for the ever smokers. So our total number of people that have not smoked was 368, which is this right here. And then the total number of people that then got the disease was 26, which is right here.
Yeah, I got that.
All right, so now we've got the risk for both groups. Any other questions before we move to the next one? Okay.
Yeah, I think I got confused about risk compared to relative risk.
Okay.
And that's what's coming up, right?
Okay, yeah. Yeah, the relative risk is the next one.
Right.
Yeah. Okay, so now we want to calculate the relative risk for comparing ever smokers versus people that haven't smoked. And we also want to calculate the 95% confidence interval. So I'm going to erase some of this so we can make room. Let's see. Since we've already got this in the assignment, I'm going to move this. Okay. All right. So how do we want to do the relative risk?
So the relative risk is going to be the risk of smokers divided by the risk in non-smokers.
Yes, that is correct.
So that's 0.091 divided by 0.071.
Yes. So I just moved some stuff over there. So that is correct. So to get the relative risk, we want to do 0.091 divided by 0.071.
Which is 1.281.
All right. Does everyone get that? And another thing to point out, so there's also a formula for relative risk, which I'll write that over here. This is visible. So remember that relative risk is A over A plus B divided by C over C plus D. So if you label your 2x2 table A, B, C, D, and then this is A plus B, and this is C plus D. And then if you plug these numbers into that formula, you should get the same answer. Because basically what we were doing when we did this here was we were doing A over A plus B. So that's what this is right here. And this is C over C plus D. And then we just divided them. Does that make sense? Okay. All right, so now we have our relative risk. So the next thing is that we need to get the 95% confidence interval for this relative risk. So what would be our next step for that?
I know there's a formula for that, but it's long.
Yeah.
This is where you use that E key,
Yeah.
which I don't understand.
Yeah.
I haven't quite mastered that.
Yeah. So let's write the formula out. So 95% confidence interval. You're going to do E raised to the natural log of the relative risk plus or minus 1.96 times the standard error of your relative risk. So like all of this here is being raised to E. And I think she had like a slightly different formula in the review slides, but I checked it and it comes out to the same way. So if you want to use the one that she has, if that's easier for you to remember, then I would go with that. But I've always used this one, so either way works. Okay. So this is our formula. So which part do we need to do first?
Well, we can plug in what we already have.
Yes.
Okay. So we have the relative risk, which is 1.28.
Yes.
So we can put that.
Yes. So we do have this. So the natural log of 1.28 comes out to be
Okay.
I have 0.246. I don't know.
Yeah.
Okay.
I'm gonna add like 0.2546, but I
Oh,
think it might
really?
just be rounding.
Okay.
What did you say? 0.2.
0.246.
Okay. Yeah. All right. Okay. So now that gives us, so that's this part right here. Okay. So we got the log of the relative risk, and then we've already got 1.96. So we also need the standard error. So does anyone remember how to get standard error for a relative risk?
There's a formula for that too, right?
Yes.
Oh yeah. Okay.
Since it's 1 divided by the number of smokers minus 1 divided the total.
So you said 1 over the number of smokers overall, or
Exposed. So it's
so
1 over 79.
yeah. So we're gonna write it first in terms of like the A's and the B's, and then we can fill in the numbers.
Okay.
Just so we'll have like the formula.
Okay.
So it's 1 over A, and then minus 1 over A plus B plus 1 over C minus 1 over C plus D. And then the whole thing is square rooted.
Okay.
And there's different versions of this too, but I've always used this one, so it comes out the same way. Okay, so knowing that, now we can fill in our numbers. So let's see. So that's 1 over 79 minus 1 over
864.
Yes, 864 plus 1 over
26.
26. And then minus 1 over, yes, 368.
Okay, hold on a second.
Okay. Let me know when you have an answer.
I have an answer. No, that's right.
It's fine. It's fine. We can,
Okay. I have 0.217.
Yeah.
Oh, okay,
yes.
great.
Have confidence in yourself. Yes. Okay. Does that make sense, Walter? Did you get, or you have questions?
I'm not quite sure.
Okay, no, that's fine.
I've got 0.0472.
Oh, no.
So
Did you square root it?
oh,
Okay.
I, and okay, that's okay.
I got one thing.
So that's a second. 0.2172.
Yep. That's it.
Close enough.
Yep. You got it. Okay. So this is our standard error. So now we're just gonna put that in up here in our equation. So now we've got all parts of the equation that we need. So we can just finish calculating the rest of that out. So I'm just gonna rewrite it over here again. So it's E and then relative risk plus or minus 1.96 times SE. So this we said was 0.246, and then you're doing plus or minus 1.96 times 0.2173. So usually what I do is you have to do this part first, since this is multiplication. And then you're going to add that to this 0.246 and then subtract from 0.246. So just let me know what you get from this part right here. Yeah, we are on part D, calculating the relative risk and then the confidence interval. So does anyone have just this part right here? 1.96 times 0.2173?
Is it 0.4259?
Yes, it is. So now you've got plus or minus 0.2549. That's what you said, right?
I have.
Or no, you said 4259. Sorry. 4259. Okay. So then, what's our next step?
And then you add that to the point. Oh, I'm sorry. And then
That's okay. You can just guess, or it doesn't have to be exactly, just whatever your thoughts are.
okay, so I added the 0.246 to the 0.4259 and got 0.6719.
Uh-huh.
And then do you do the next part, like the subtraction, or do you do like
You can do it either.
Okay.
You can do it either way, because you just need to like this is like the last step for like this part, and then you just have to like exponentiate it ultimately. Like you could do the plus and then the minus, and then you get both exponentiate each one, or you can just go ahead and exponentiate this one before you go on to the next one.
Okay.
I just just did the subtraction and got negative 0.1619.
I got the same.
Yeah, I think it does come out negative. You said negative point.
0.1619.
Yeah, I think that's what I.
I know 0.1799. I don't know.
Yeah. Yeah, I have 0.1799. Yeah. It's probably just rounding, because if you round it differently, then it'll give you slightly different answers. So I usually try not to round until I get to the end, but it's still pretty close. Okay. So I'm just going to do 0.1799 for this one. Okay. So you've got your plus and you got your minus, but you still need to exponentiate this because this E is still out front. So basically it's just like you split it into like you're doing the plus part here, and then you're doing the minus part in the second step, but you need to still exponentiate this answer. So you just need to do e to this number for both of these. Sorry, that looks bad. Can you see what I'm writing here? Okay.
I've lost my way.
Okay.
Okay.
Where did I lose you?
Okay, so I had up to 0.6719. Then I guess it was on the minus. So it's still 0.246 minus what? The
0.4259. So it's just,
0.42.
it's basically like we just took this step right here and we broke it into the plus and then the minus. Because before it was just written plus or minus. So we just broke it into those two individual steps so you could get each number.
Yeah.
So what do we have for e to this number right here? The 0.67. This one?
Yeah, 6719.
It's just this plus that.
Oh, okay, I see what you did.
Yeah.
So I forgot how the E thing works. But is it the EX that's over the LN?
Yes.
Okay.
Okay. Any ideas on this one?
I got 1.957.
Yep. I'm just gonna put 1.96.
Okay.
And then, did you get an answer for this one too?
I did 0.8, I guess 35, or would it be 0.84? Would you just? Oh, okay.
I don't know. Usually I just do 2 decimal places,
Okay.
but she'll tell you on the exam how many she wants.
Oh.
But usually we just do 2. Okay. Does everyone see how we got that? All right, so those are your final boundaries for your confidence interval.
Okay. Now my problem is that I got for the 0.799, I got 1.197.
When you did 0.246 minus 0.4259.
Yeah, I got the 0.799.
Yeah.
But then when I do E parentheses negative 1 point,
It's negative 0.1799.
Now not get anywhere.
Okay, good. All right, so our final confidence interval, you would just write it with the smallest one first. You put 0.84, comma 1.96. And so usually what I do is after I get this, I go back and look at my original relative risk, and it should be like about halfway in between this interval. So 1.28 is pretty much halfway in between this. So we know that this makes sense because it's supposed to be like the boundaries around your relative risk that you calculated earlier. Okay, so then we want to interpret what this means. So how would you interpret? I guess first we can start with interpreting this relative risk, and then we can interpret the confidence interval with it. So how would you interpret this 1.28?
See, there's a 1.28 relative risk of people who smoke having arm as opposed to people who don't. All right, I guess that's not
Almost. It's you're almost there. It's just a little bit of like clarification with when you're describing this number. So you would say that there's 1.28 times the risk
Okay.
for smokers compared to non-smokers, or you would say smokers have a 28% higher risk compared to non-smokers. So you can either interpret it as like 1.28 times higher or 28% higher.
How do you go from 1.28 to 28%?
Because this is interpreted as, so like if you think about it, this is like a ratio. If there's 1.28 for smokers, then like the non-smokers is like 1. So the difference is that 0.28. And so that's 28%, like 1.28 minus 1 is 0.28. And then you can convert that to a percent. So it's 28% higher in the smokers compared to the non-smokers. So anytime you have a risk that's like greater than 1, you can interpret it as like how much percentage higher is it.
If it's less than 1, you can't interpret it that way.
You can, but it's saying that it's protecting you. So it's like if you had 0.6, then it would be the risk is 40% reduced for the exposed compared to the unexposed. So it's reducing your risk instead of increasing it.
So how did you say it the first time? So there is
the risk of developing ARM is 1.28 times greater in smokers compared to non-smokers.
the risk of doing error is 1.28. Did you say percent?
Times.
Okay.
Yeah. So you want to make sure you say who you're comparing. So you're comparing smokers to non-smokers, and that you're saying the actual amount. So the the magnitude, that it's 1.28 times greater. And then for our confidence interval, what would you say in terms of interpreting what this means? Has she talked about interpreting relative risk and confidence intervals? I think she had something in the slides. I remember seeing the review slides.
So would you say with 95% confidence, the relative risk would be between 1.95 and 0.84?
Yes. Mm-hmm. Yeah, that's right. But I would probably start with the lower and then the higher. But yeah, that's correct. So you would just say we're 95% confident that the true relative risk value falls between the range of 0.84 to 1.96. And then what else about this confidence interval would you want to talk about? So think back to when you're trying to determine if something is significant. What would you look for? Yes, yes, that's right. So if there's a value of 1 in your interval, that means that your relative risk that you calculated for that association is not significant. Because if you find a 1 in here, remember that a 1 means that there's no association. That means the risk in the exposed and the unexposed is the same. And so if that value of 1 is falling within your range of confidence, then that means you can't rule out that 1 is a possibility. It is possible there's no association at all because that number is in there. So because of that, you would conclude that this relative risk value isn't significant because 1 is in the interval. Does that make sense?
Yeah, but it's kind of blowing my mind. Oh!
Yeah. I think she did a drawing where she said here's your interval. So let's say 1.28 is right here. And then you've got 0.84 and 1.96. So this is the range at which you're 95% sure. I know the true value is in here somewhere. If a 1 is in here, how do you know that 1 isn't the true value? Because you already said, I know the value is in here somewhere. It has to be with 95% certainty. So if you can't rule this number out, then you can't state at a level of 95% confidence that there's no association. So that's why you would say, well, this isn't significant because it's possible there's no association. So that's the reasoning behind that. Okay.
I think I just understood that for the first time.
Yeah, it's a little weird. but I like to think about it visually like this. Okay, so I'm going to move on to the last one on here. So we did the interpretation. So now this next question is a little bit different. So part E is saying, assuming causality, what is the proportion of cases of ARM that could have been prevented in the population of males aged 43 to 86 in Beaver Dam if the smokers had never smoked? So think about what this question is asking and what this might be related to.
Now, is that an attributable risk?
Yes, yes, it is. So this is looking at population attributable risk, or I think it's also called like population attributable fraction. So basically, you're trying to calculate out of the original population that they're studying what proportion was due to smoking. And so, like, what proportion would have been prevented if they had never smoked? So, there's also a formula for that. So, I'm going to erase. I think we need this. So, is everyone okay with me erasing this part?
Mm-hmm.
Okay. So, looking for the population attributable risk. So the formula for that is incidence in the total population minus incidence in unexposed divided by incidence in total population. Okay. Is everyone familiar with this? Okay.
So is incidence in total population, is that going to be the incidence of smokers plus the incidence of non-smokers?
Yeah, it's basically, it's you're looking at overall, so you're not splitting it by smoking and non-smoking. You're looking at the total population. You just want to look at, out of everybody, how many people got the disease.
Okay. So is that the 0.091 plus 0.071?
Well, that's already been, like, you can't just add, well, actually, I don't know if that comes out to the same thing or not. Let me see. Yeah, you wouldn't be able to add those together because those have already been like divided by like the individual groups that they came from. Like those are ratios,
Oh, you're right.
or not ratios, but like there's a different denominator that was used in each of these.
Right.
So you can't just like add them together. So you just have to like identify based on this table, what's your total population at risk, and then what's the number of new cases in your total population. So you're just looking at everybody.
So is that going to be that 1232?
Yes. So that is your denominator for calculating the incidence in the total population. And here, incidence and risk are the same thing. Just to clear that up.
Just here?
Well, in general, when you say incidence, it means risk. So as long as it doesn't say incidence rate, it's the same thing. Incidence and risk are the same thing. So this is your denominator. So then, and this is looking at the total population. So then what's your numerator?
1232 minus 26.
Not quite. So looking at this table, how do you think you might get the total number of people that have ARN? Like regardless of what the exposure is, because we don't care about that.
So it's 368, right?
The 105?
It would be the 105. Because the 368 is the total non-smokers.
Oh.
We want the total ARN because that's the disease. So that's this number right here, 105. So I'm following that.
I guess I got a little confused because I'm looking at, I guess like the formula itself, like where it's incidence of total population over incidence of total population. So I guess I'm kind of confused. I'm looking at them as being the same thing, but I guess
it is the same. It is the same thing. But in the numerator, you're going to subtract the incidence and the exposed from the incidence unexposed. Because this is considered like your baseline risk. And so you're trying to take away whatever the baseline risk might be to just get what would have been attributed to the smoking. Does that make sense?
No, so
think about it like you're looking at everybody overall.
Okay, that part I get.
And then you're going to subtract from that, well, what was the risk in the people that were not exposed to smoking. So that's going to go right here. And so the idea is that so thinking in terms of like what would cause a disease. So you have like, just like your baseline risk of getting something, and then there's like the risk from some exposure. So the thought is that like these are the two ways in which you would get a disease, and this would add up to like what the total risk is in the overall population. So just conceptually, this is how we're thinking about this. So like if you've got this total risk in the population, which is this, and then you're subtracting the baseline, which is your unexposed amount of risk, that just leaves you with the risk due to whatever your exposure was. And so that's why you're subtracting the unexposed from the total risk in population. And then you take that and then you're dividing it by, again, this total risk in the total population. Oops. So we just need to plug this in now. Have I confused you?
I'm sorry, you have completely lost me. I'm sorry. I'm not following at all.
Okay, so think back to like what population attributable risk is. Like you're trying to figure out, it's like you've got this certain amount of risk that is present in the population, which is this right here. And you're trying to figure out, well, what proportion of that is due just to this exposure? Because right now, this number is due to anything. It could be just you by chance getting this ARM or some other exposure. And then some of that could be due to the smoking, which is what we looked at here. So it's like you're trying to break down out of this total amount of risk, how do I isolate the proportion that's just due to the smoking? So you have to take that total amount and subtract out the part that doesn't have anything to do with smoking. Because the incidence in your unexposed group, this is a measure of your chances of getting this disease due to other causes, because these people did not smoke. So by you taking this risk away from the total, it just leaves you with the risk for smoking. Does that make sense? Okay. So you're trying to just like isolate that portion that's just smoking. So you take everything that you have and you subtract the unexposed amount, and then you divide it by like your total amount again. Maybe once we put in numbers, I'll try to like explain it a little differently. So the incidence in the unexposed, we said was 26 out of 368. So that comes out to 25. So you have 0.085 minus, we already did this earlier, it was 0.071, right? And then divide it again by 0.085. Okay, so you just do this minus that, and then divide it by the 0.085, and it comes out to be 0.1710. Does that make sense? And then if you just convert this to a percentage by multiplying by 100, you get 17%. So this is just saying that 17% of this original 0.085, 17% of that risk is due to smoking. And so that means that if those people had never smoked, that 17% of that risk would have been reduced. So looking at this original 0.085, which is what we started with, we took away the part that was just due to other random things, and theoretically that leaves us with the part that's due to smoking. So if I label this as this is everything, this is the part that's like not due to smoking, and this is everything, then you're left with smoking out of everything. So it's the proportion of all the risk that's just due to smoking. Because a proportion is basically just a ratio and then you convert it to a percentage. So it came out to be 17%. Does that help at all? It's hard to like explain, but I hope that helps a little bit. So this is saying 17% of the cases would have been prevented if they had never smoked, because this is the part that's due to smoking.
See, part of my problem is I'm looking at that and I'm trying to figure out why aren't the 105 over 1232 canceling each other out, and you just have the 26 over 380.
Because you're subtracting this from it.
Before, right?
Yeah, this isn't multiplication. Like
Right.
You can't cancel unless it's multiplication.
Exactly.
You have to do this first. I mean, think about it like if you had, let's say you had like a group of 100 cases of something, and you said, okay, I know that 60 of them are due to smoking, and then the other 40 are due to like other causes. So like basically what we're doing here is we're saying like, if I want to look at the proportion that's just due to smoking, then you would look at the total. It's basically like you're taking the total and then you're doing the total minus the other causes, which is just 60 over 100. So it's the same kind of concept. You're just trying to get a percentage. Yeah. Okay. So I haven't thoroughly confused you. I would just try to look through, I think she had a couple slides on it, so that might help to clarify a little more. So I just wanted to go through the last two multiple choice questions that are on study designs, and then we'll wrap up because I don't want to go too far over. So question number 2 is asking Which of the following best describes the retrospective design where subjects are sampled by disease status and is often used when the investigator is interested in rare diseases?
So ridiculous. I'm reading the definitions and I have to read it over and over.
Yes. Yes, so it is case control. And the key here is that they're saying they sampled by disease status. So that means that they went and found their study sample based on whether or not they had a certain disease. So if they went to some hospital records or something like that and they found people that had the disorder, and then they went and found people that didn't have it, and then that was their study sample.
So when I see the word sample, does that point me in the direction of it always being a case control?
No, because every study has a sample. It's just how they get it that determines what study design it is. So if they're gathering their sample by first saying, do you have this disease or do you not, then that's going to be case control. Because they're going to some records and they're saying, this is how I'm defining who's going to be in the study by this disease status. But if they're, let's say, they're just picking like a cohort of people and then they're asking them about, were you exposed to this? And then following them, that's a cohort study because they didn't ask about their disease status at the beginning. They just asked them about exposures. So that would be, but they're still looking at a sample.
Okay.
Yeah. So it has to do with like how they define the sample. Okay. And then the next question says, which of the following best describes the study design that can be either retrospective or prospective and is often used when the investigators are interested in rare exposures? Any thoughts?
Retrospective.
So have you seen those describing a certain?
That way,
Oh,
on the slides, I can't remember.
I think I remember seeing something about it.
It seems like that might be a prevalent studies. Right.
Not quite. Because it says that they're like looking at an exposure, so that means they're doing some type of like analysis of like future risk for a disease. And a prevalent study would just be looking at, well, who has this disease right now?
So intervention trial?
Not quite, because they didn't. They're not saying that they're doing an experiment or randomizing people or anything like that. Yes. So prospective cohort and retrospective cohort are two specific types of cohort studies. And I think the book talks about it as well. And there's like a couple diagrams that they have that explains like the differences between the two. But with both of them, you would use them for rare exposures because you are sampling and getting your sample based on like what they were exposed to. So that's something that you're assessing at the beginning of the study. And so when it's talking about rare exposures, that would be a good design to look at rare exposures, because you're able to look at that initially and get your sample based on that, versus like trying to look at it later and you don't know what exposures your sample is going to have because you didn't determine that from the beginning. Yeah. So I would just recommend like looking back through that review slides, because I remember seeing a brief slide on it. It was kind of like at the bottom of one of the slides, but yes.
I'm so sorry. Is it possible you could give like an example, like of an ecologic?
Yeah, so an ecologic study is basically one where you're just looking at things at a group level. So if you're trying to look at the association between socioeconomic status at the county level to preterm birth at the county level, that would be an ecologic study, because you're not looking at individuals, you're looking at data that has been summed over an entire county. So you're not just looking at like the individual people. And so with that study design, a lot of times it is useful because it's easy to do, like the data is available readily, and so a lot of people do them. And it's also good to like develop hypotheses preliminarily, like if you don't know how SES might affect preterm birth. I mean, we know some of that now, but if it were something you didn't know about, it would be good to do an ecologic study. But the disadvantage is that you can't make assumptions at the individual level, which is, there's a term for that. Do y'all remember what that's called?
When you can't make assumptions at the individual level.
Mm-hmm. The ecologic fallacy. Yeah. Yes. All right. So any other questions before we end? Didn't get to the last one, but I can send the answer key out.
What is the last?
Yeah. I'm sorry, what did you say?
No, I thought you were going over the past study.
So that one is a case control study, because it says they went to the hospital records to find cases of mothers with preterm and controls that did not deliver preterm.
I know that I have like a tutoring session after this,
Yeah.
which is fine.
Yeah.
I mean, I don't know if you mind, but if you don't mind, like we could go over the last
Okay.
question. I don't mind. Like, giving us
Okay.
some time.
Yeah. I just didn't want to cut into.
Yeah, no, like, I remember that I have the time out, but that's fine. I mean,
Okay.
we all need to go.
And I don't know who you got at 5, but I got you at 5:30, so
Yeah.
I'm not going anywhere.
Yeah.
Yeah, I don't have anybody at 5, so I can.
So hey, it's like, so we're locked in.
All right.
Let's go.
Okay, so, well, we kind of did the question A, but we can still read through that one if you want. Do you want me to go through more about
Go
this?
through everything on this paper and then some
Okay. Okay, so number 4, it says, in 1977, researchers at Yale University wanted to study the association between mothers' socioeconomic status and preterm delivery. The study team gathered hospital records from the Yale New Haven Hospital in Connecticut during 1997 to find cases of mothers who delivered a preterm infant and controls that did not deliver a preterm infant. Researchers then also collected data on the mother's SES in 1977. The table on the following, or that's supposed to say the table below, contains data for mother's socioeconomic status for those with and without preterm delivery. Okay, so it's asking type of study design. And so, as I mentioned, in the paragraph, it states that they went to the records to find how many mothers had a preterm infant, and then how many didn't have a preterm infant. So preterm delivery, since that's their quote disease outcome, and they're defining their sample based on that, that would be the definition of a case control study. And anytime you see that they have cases compared to controls, that's usually an indicator that it's a case control study. Does that make sense? Okay. All right, and then so they gave us the data there. So they have several different levels of SES, and then they show for each socioeconomic status level how many were a case and then how many was a control among each of those levels. So the next question is asking you to calculate the appropriate measure of association for the study, as well as the 95% confidence interval. And one thing I forgot to mention, sorry, there's like some information missing from this. So it's supposed to be comparing the measure of let me start over. Calculate the appropriate measure of association to compare the lower SES category to the upper SES category, because they've got like several different ones on there. And sorry about that, I meant to like put that in there, that those are the two categories that you're comparing. So lower compared to upper.
Okay, so my first question is, do we count the middle at all?
No, so it's just asking you to look at the lower and the upper.
So not
levels.
lower middle or upper middle, just
No.
lower and
Yeah.
upper.
Yes. Sorry, I meant to ask. I hope you don't have all of this already.
Yeah.
Okay. Started erasing it. Okay, so first question. So we said this was what type of study?
Case control study.
Okay. So what measure of association do you usually calculate for a case control study? Any guesses? You can just throw something out there.
Incidents.
Not quite. So what exactly is a measure of association?
It's a comparison,
Yes.
right?
Mm-hmm.
And
so an example of a measure of association would be a relative risk, right? Because we're looking at how the risk compares in one group compared to the other. So usually it's looking at exposed compared to unexposed. But here, for this study design, usually you would use an odds ratio because the way that you set up your sample, because you're starting with people that already have the disease, it's not going to match what the actual true prevalence of the disease might be in the population. And so you wouldn't want to try to measure risk from that. So that's why you typically use an odds ratio. Does that make sense? So I think she has like a couple slides on like situations when your odds ratio and your relative risk would be similar. But unless you have a disease that's rare and you know that the way you got your sample is reflective of how prevalent that disease is in the population, you would just want to use the odds ratio.
I should just
Okay.
but continue.
Okay. I can talk through it again, like once we actually put the numbers up, and I'll show you what I'm talking about. Okay, so we said we're doing an odds ratio. We want to compare the lower to the upper SES. So to do this odds ratio, what's the first thing that we need to do? Table? Yes. We need to make our 2x2 table. So so what's going to go along each of these sides here?
Well, cases and controls at the top.
Yes.
And upper and lower.
Yes. So in this situation, we want upper SES to be our reference group because higher SES tends to have like more positive health outcomes. So I'm going to put upper down here and then lower here. Does that make sense?
Mm-mm.
So
No.
you usually put, think like before when we were doing exposed and unexposed. Unexposed is usually like your group that has the lowest amount of risk. And so we know that poverty increases your risk for diseases. So people that are in more poverty are going to have higher risk for things than people that are not as impoverished. So you want the people that are in the higher SES category to be your reference group.
So does that necessarily say can I make any assumptions here that like in that column the top number is always going to be larger than the bottom number?
Yeah, so normally, yes, that would be how it would work if you kind of already know, because in this case, like since we know that a lower SES is gonna increase your risk, then yeah, you will have higher numbers in this row compared to, like here compared to here. But the point of doing this is so that you can actually show it. So you can show like how much higher. Because ultimately you're going to get an odds ratio that's going to compare this lower to the upper, and you're going to be able to say it's this many times higher in the lower compared to the upper. Okay, so one other thing I'm going to write in, just so we'll remember. So I'm going to write that a case means that you had a preterm infant. And then a control meant that you did not. So no preterm infant. Okay, so now we need to fill these numbers in. So what did they give us?
So 53, 40, 11, 58.
Okay, so 53.
Then 40 in controls.
Not quite.
No?
So this is still among
Oh, that's right. That's
SES.
right.
58.
So it's going to be 58 then.
Yes. Okay. And then 11. Uh-huh.
40.
Yes.
Then we have to do the totals.
Yes.
So 53 plus 58 is 111.
Uh-huh.
And 11 plus 40 is 51.
Uh-huh.
Then on bottom, we do. Okay, so then that's 162.
Uh-huh.
And then we do the totals vertically.
Yes.
So 53 plus 11, that's 64.
Mm-hmm.
And then 58 plus 40, that's 98. Yeah. That should equal to 7.
Yes. Okay. So everyone understand where we got these from? Any questions? Okay. So now we want to try to calculate our odds ratio. So what do we need to do to get that? So one thing we can do is we can label these cells again, A, B, C, D. Does anybody remember the formula for the odds ratio? Okay. So it's A times D over B times C, if you label your cells that way. And I can go into why it's set up this way. I don't know if that would confuse you
I
though.
don't need to know why. I just need to know how to do it.
Okay. I won't go into that.
So, I don't know about y'all.
That's fine.
Yeah, for
Yeah.
now.
A lot of this is just memorize the formulas.
Yeah.
Okay. So let me know, based on this, what numbers, what are we doing here? So we're doing 53 times 1. Uh-huh.
On the 58.
Uh-huh. That comes out to
3.32.
Yeah. Don't say it with a question mark. You got it.
The
confidence. Yes.
Why did I get 0.332 instead of 3.32?
Maybe you hit a decimal somewhere.
So it is 212 divided by 6. See, I'm doing 212 divided by 638, and I get 0.332.
It should be 2120, 2,120 divided by.
Oh, okay. That's
630. Yeah.
Yep.
Okay, cool. All right, so we have our odds ratio. So how do we interpret this? It's 3.32. It's going to be similar to how we interpreted the relative risk, but slightly different.
So would you say there is that women who are from a lower socioeconomic status are 3.32 times more likely to have a preterm birth?
Almost. So you forgot your comparison group because you got to say compared to
women who are from a upper
yes.
socioeconomic.
Yes. And then also you would say, instead of likely, you would have to say the odds. So you would say women from a lower socioeconomic status have 3.32 times the odds of having a preterm infant compared to upper SES women. So you have to make sure you make that distinction when you're doing an odds ratio versus a relative risk, because odds is not looking at risk, so you can't say likely, you have to say odds.
So I wouldn't say 3.2 times more likely. I'd say,
You could say 3.32 times the odds, or you could start by saying the odds are 3.32 times greater. But the point is that you have to make sure you're saying odds and not likely.
The odds.
Yeah. Does anybody need me to repeat that again?
The odds are 3.32
times greater.
Times greater.
Okay. Yeah. Okay. So yeah, going back to what you were saying earlier, actually, I think you mentioned I can't remember who mentioned it, but you said well, we already know, we're gonna have a higher number here for the people that are low SES compared to this number, but by doing the odds ratio, it tells us how much higher. So we know the odds are 3.32 times higher in lower SES versus upper, because you can't just compare the raw numbers, because it could just be that you had more low SES people in your sample. So by doing this odds ratio, we can compare and get the actual amount of how much different it is between those two groups. good with this? Any other questions? Okay. So the next part is asking for the 95% confidence interval. So what do we need to do to calculate that?
Formula.
Yes.
Is it really the same as the one for relative risk? You just replace the RR with the OR? I don't know.
Yes, you do that, and then there's one other thing that's different. So the standard error formula is different for an odds ratio compared to relative risk. So before I erased it, but it was 1 over A minus 1 over A plus B plus 1 over C minus 1 over C plus D. But here it's going to be...
it's all pluses.
Yeah, it's all pluses. And we're just looking at A, B, C, and D. So I'll write that out. So this is for this is the relative risk. So now it's E natural log of the odds ratio plus or minus 1.96 times the standard error of the odds ratio. And standard error of the OR is square root 1 over A plus 1 over B plus 1 over C plus 1 over D. I'll write the other one again, just in case you want that. Okay, so that's the comparison. This is for the relative risk, and this is for the odds ratio. Okay. This should be standard error. Okay, so similar to what we did last time, what do we need to do first?
There's the natural log for the natural log of 3.32.
Yes.
Okay.
Mm-hmm. So you basically just look at your formula and you're like, okay, what do I not have? I don't have the log of the OR and I don't have the standard error. So you can start by just doing the log of the OR. So ln of 3.32 comes out to be,
I have 1.199. I don't know how many both nines, but 1.199.
we can just round it to 2 decimal places.
Okay.
So we can just do 1.20. So we got that. Now we need to calculate
Standard error.
yes. So it's going to be square root of
1 over 53 plus 1 over 58 plus 1 over 11 plus 1 over 4.
yes. Mm-hmm. Anybody have an answer?
I have a number.
Okay.
That's correct. 0.1520.
Just for this part?
Yeah, when I squared it, no.
Oh, did you say you square rooted
I
it?
did.
Okay.
Should I have done or?
Yeah, you're supposed to square root it, but I had something a little bit different.
Okay.
Maybe something happened with the calculation. Plus 158 plus 140. I think maybe you said you got like 0.152.
Yeah.
I think you just needed to square root it because I got that before I square rooted it.
So I did 0.389.
Yes,
Oh,
that's right.
Okay. 0.397.
Yes. So 0.3. I'm just gonna put 390. Okay. So that gives us the standard error. So now, what do we need to do next?
Make it
Yeah.
0.390 instead of.
Yeah,
Why should you go 0.390 instead of 0.39?
because I got 0.3989. I guess I could make it 0.3899.
Because I had 0.3898.
0.3976.
I didn't get that. I don't know. I didn't round it or anything. So
And I'm also doing it on my phone.
okay. Because I just like put it all in together and it gave me 0.38989. So yeah, I think if you like, I don't know, maybe it's rounding, I'm not sure. But
Yeah, because I rounded every individual one, like 0.019 plus 0.017 plus 0.091 plus 0.025 to get 1.52.
yeah. Yeah, I didn't do any rounding on mine. I just put it all in at once. So I'm
I
not
should
sure.
trust myself.
Well, it helps on these because you can see the whole thing at one time. So I can tell like whether or not it's incorrect correctly. Yeah, I'll just do that. Alright. We'll just stick with this. I usually try not to round it until the very end because that helps too. Okay, so are you okay then?
Yeah.
Okay. Okay. All right. So next step.
You mentioned earlier following order of operations. So multiply, after you plug in the numbers, multiply the 1.96 times 0.39.
Yes. So I'll just rewrite it over here. So we've got E. So we've got, this is 1.2 plus or minus 1.96 times 0.389. 0.3899. And so you're right, we need to first multiply the 1.96 times the 0.3899, which is
was it okay if I round that to 0.390, or should I keep it?
yeah, that's fine.
Oh, okay.
Yeah, we can just.
I got 0.7644.
Okay. Does everyone else have that?
Yeah.
Okay.
Actually,
Okay.
you know what? I got.
I mean, it's gonna be a little bit off.
I got 0.076, so I do something.
Maybe did you put in
throwing in the
decimal? Yeah. Okay.
Did it again.
Gotta be careful.
That's gonna kill me.
Yeah, it's easy to do. Always check and double check if you can. All right, so now we've got this. So we need to do 1.20 plus 0.7644 and then 1.20 minus 0.7644. So remember what we did last time. We split it up into like two different steps. So we got this one, that one's the plus, and then this one is the minus.
For the 1.20 plus 0.7644, I got 1.964.
Okay.
Is it fine that I just that I kept it at just 1.96, or did I need that extra digit?
I mean, when you're doing this on the test, I think that it's best to not round. I think you should keep like at least 3 or 4 decimal places as you're going along. Because we're doing like so many steps. If you round it too much, by the time you get to the end, it's going to really affect your answer. So you want to try to either not round it at all as you're going along, which is kind of hard unless you have like a calculator that will let you do, like you can see all the steps that you're doing. But if you can't do it that way, then I would say keep at least 3 or 4 decimal places as you're going along. So, yeah. I would say 4. Just do 4 decimal places. All right. So we said 1.20 plus. Oh, we already got the plus. So then the minus.
43.6.
Yes. Okay. So now what's our last step?
Exponentiate.
Yes.
Oh, that's right.
The 1.964 is is kind of a big number, but I got 7.127.
Yes.
Yeah, I got 7.127.
I have 7.1. Yeah, that's pretty much the same thing. Yeah. Yeah, like I said, the rounding will make it not exactly. So it depends on like how you rounded it throughout.
And then for the 0.4356, after exponentiating, I got 1.545.
All right.
1.546.
Yep, that's right. Cool. So these are our final boundaries for the interval. So how would we write this? Do you remember how we wrote the last one?
The lower number first.
Yes.
Oh, yeah, okay.
So 1.55, comma, 7.13. Okay. So
Okay, I got some crazy numbers. Oh, it's the same crazy numbers. Okay.
yeah.
I'm like 7.
Yeah.
What kind of range is that? 7.
Yeah. Yeah, it's a little like weird at first.
2 hours is not enough time. I know.
Yeah.
Calculate. Like even the last one, I think it took me like an hour and 40 minutes to finish that one. Just go over it again. No or less calculation.
Yeah, it's a lot of
I
calculations.
struggled to get that 21 points.
Right.
I was like, oh, at least I got over half.
Yeah. Most of my online classes have been like 3 hours for exam.
Wow. Yeah.
2 flies by.
Yeah, it does. Okay, so everyone got this?
Yeah.
Okay, so like we did last time, how would you interpret this interval? What would you want to say about this?
Um,
Yep, that's right. Keep going.
You
got it.
That's the easy part. I can say that already. 95% confidence. I have no idea.
So
Did you say like a true ratio?
Yeah. The true odds ratio is captured in this. Because remember, the 95% confidence interval is basically you're trying to calculate, okay, what are the boundaries that I know with 95% certainty that the real value for this population is going to be inside of that. So we would just say we're 95% confident that the true odds ratio is captured in the range between 1.55 and 7.13.
The true odds ratio. Did you say falls between?
I think I said falls last time, but it's more accurate to say it's captured within the range, because it's not that you're like drawing some arbitrary interval and it just is falling in there, but like you are capturing the range that you know with 95% certainty that the true value is in there. So I would say captures is probably a little bit better word to use. I mean, what else would you want to say about this? Or what we talked about all
Is it significant?
Yes.
So, well, this would be significant because it's the lower range is higher than 1.
Yes, that's right. There's no 1 in this interval. So that means it is significant. Yeah.
This is the first time I've ever understood
Yeah.
that.
I'm glad that you're going to break through.
What did you say? Wait. What was the figure?
The idea that because there is no 1 in this range, that means it is significant. Because if it was 1, that means it could go either way.
Yes.
But because it's more than 1, then that makes it significant. But if it was like less than 1, like if it was like 0.44 all the way up to it's still not significant because 1 comes in there somewhere.
Yeah.
But because we're above 1, that makes it significant.
Yes.
And this is the first time I have like captured that.
Yeah. I'm glad that makes sense.
Bravo.
Yes.
Yes.
I'm glad that I can help you to come to that breakthrough.
That's a major breakthrough.
So yeah, here you would want to say the association is significant because there's no 1 in there.
Non-stop. Oh, I have a question.
Yes.
For number 1 that I missed.
Oh yeah.
Is that a cross-sectional study?
Actually, it isn't.
A cohort?
Yes.
A prospective cohort.
Yes, because they're following them. Yeah. Because remember, for cross-sectional, you want to remember that it's a snapshot in time. They are.
Isn't this after 5 years?
Yeah.
Okay.
If they are just measuring the exposure and the outcome at the same time, then that would be cross-sectional. But anytime you see that they're following somebody, then it's either going to be cohort or experimental.
So you said they're measuring which 2 at the same time?
The exposure and the outcome. Okay.
Thank you. Thank you.
Yes, you're welcome. I don't know if someone else has the room, so I don't think there's anybody in here, but if somebody comes, we would have to leave, so. All right, well, thank you all. I hope this was helpful.
Thank you so much.